Intensive practice 4.3. Questions number 1. Given log base 5 of 3 is equal to 0.683 and log base 5 of 7 is equal to 1.209. Without using a calculator or 4 figure tables, calculate log base 5 of 1 and log base 7 of 75. So always refer to all the law of the logarithms to help you to solve for the questions. So first, we want to find the value of the log base 5 of 1. Now, if you refer to the law here, log base a of 1 is equal to 0. Therefore, log base 5 of 1 is equal to 0. Another method is that, or you can change these log forms into the index form. Therefore, first I'm going to let this log base 5 of 1, the answer equal to x. Therefore, when I change this to index form, it will be 5 to the power of x is equal to 1. So, the x here has to be 0 because any numbers to the power of 0 will give you the answer of 1. So, therefore, the x, which is the answer, is equal to 0. Next, we're going to solve for this log base 7 of 75. Now, we're going to use the informations given in the questions to find the value. So first, I'm going to change these logs to base 5. So using the law here. So it's going to be log base 5 of 75 over log base 5 of 7. And for the numerator part, this 75, we can write it as 25 times 3, which is also equal to 75. And the denominator part, the log base 5 of 7, now I'm going to replace it with the value of 1.209. So next, refer to the product law. The numerator part, I can write it as log base 5 of 25 plus log base 5 of 3 over 1.209. And this 25, I can write it as 5 squared. Therefore, log base 5 of 5 to the power of 2, refer to the law here, it will be equal to number 2. And this log base 5 of 3, we're going to substitute it with the value given, which is 0.683. Then we're going to divide it with 1.209. Solve this, then you're going to get the answer is equal to 2.2192. Questions number 2. Given log base a of 3 is equal to x and log base a of 5 is equal to y, express log base a of 45 over a cubed in terms of x and y. So we need to convert the log base a of 45 over a cubed to log base a of 3 and log base a of 5 so that we can have the terms x and y. So first, the log base a of 45 over a cubed. Using the divisions law here, I can write this as log base a of 45 minus log base a of a cubed. So the 45 we can write it as 9 times 5. And log base a of a to the power of 3, refer to the law here, is going to give you the answer of 3. Now, using the product law, I can write the log base a of 9 times 5 as log base a of 9 plus log base a of 5 minus 3. And the number 9, we can write it as 3 squared. So log base a of 5 is equal to y. So I'm going to substitute it with y here. Now, using the power law, move the number 2 to the front. So it's going to be 2 times log base a of 3 plus y minus 3. So this is the same as 2 times x. So therefore 2x plus y minus 3 will be the answer. Questions number 3. Determine the value of log base 4 of 8 plus log base r of square root of r. So this number 4 and the number 8 here, we can convert it to the number in base 2. Therefore, for the log base 4 of 8, I'm going to change it to the log with base 2 using the law here. So I'm going to get log base 2 of 8 over log base 2 of 4 plus log base r of r. The square root we can write it as the power of 1 over 2. Now this number 8 we can write of log base 2 of 2 cubed over log base 2 of number 4 as 2 squared. So log base r of r to the power of 1 over 2. Now refer to the law here, is going to give you the answer of 1 over 2. So log base 2 of 2 to the power of 3, again refer to this law, is going to give you the answer of 3. And the denominator part will give you the answer of 2. Therefore, solve this is going to be 4 over 2, which is equal to number 2. Questions number 4. Without using a calculator or 4 figure tables, simplify log base 12 of 49 times log base 64 of 12 divided by log base 16 of 7. So first, I can write this as log base 12 of 49 multiply log base 64 of 12. I'm going to put a bracket here, divide by log base 16 of 7. Now, if you look at all the numbers here, they have connections to each other. So for example, the number 12 here with this 12. This 49 we can write it as 7 squared, which has connection with this number 7. This 16 we can write it as 4 squared. And this 64 we can write it as 4 cubed. So to solve for these questions, I'm going to change all the log here to log base 7 using the law here. So here I'm going to get log base 7 of 49. So 49 straight away I'm going to write it as 7 squared over log base 7 of 12 times. So this one we're going to change it to log 7 as well. So it's going to be log base 7 of 12 divided by log base 7 of 64, which is equal to 4 cubed. Divide by, so this one changes to log base 7 as well. So it will be log base 7 of 7 divided by log base 7 of 16, which is equal to 4 squared. So here log base 7 of 12, we can cancel it. And this log base 7 of 7 to the power of 2, according to the law here, is going to give you the answer of number 2. Therefore, here you're going to have 2 over, so using the power law, I'm going to move this 3 to the front. So it's going to be 3 times log base 7 of 4. So here I'm going to change it to multiplication. So I'm going to flip this over. Log base 7 of 7, this will give you the answer of 1. So it will be, so this number 2, we're going to move it to the front. So it's going to be 2 times log base 7 of 4 over 1. So this log base 7 of 4 and this log base 7 of 4, we can cancel it. Therefore, you're going to get 2 over 3 times 2, which is going to give you the answer of 4 over 3. So for this question number 4, there are actually numerous ways to solve this. Just this case, I'm using the base 7. So you can try to solve this using the other base like log base 10 as well. Questions number 5. Given log base 10 of x is equal to 2 and log base 10 of y is equal to negative 1. Prove that xy minus 100y squared is equal to 9. So first, this log base 10 of x equal to 2. Now, using the law here, we can find the value of x. So we're going to convert this log form into index forms. Therefore, this will be x equal to 10 squared, which is going to give you the answer of 100. And for log base 10 of y equal to negative 1, again, we're going to change these log forms to the index form. Therefore, y is equal to 10 to the power of negative 1, which is equal to 1 over 10. So now to prove this, we're going to start from the left hand side. So xy minus 100y squared. So we know that x is equal to 100, so it's going to xy is going to be 100 times 1 over 10 minus 100, so the y is 1 over 10 squared. So here we can simplify this. So you're going to get 10 minus 100. So 1 over 10, when you square it, you're going to get 1 over 100. So this 100, we can cancel it. Therefore, it's going to be 10 minus 1, which should give you the answer of 9. Therefore, we already proved that xy minus 100y squared is equal to 9. Questions number 6. Given log base 5 of 2 equal to m and log base 5 of 7 equal to p, express log base 5 of 4.9 in terms of m and p. So the base are the same, which is 5. So this 4.9, we need to change it to the numbers which contain 2 and 7 so that we can have the terms m and p. So log base 5 of 4.9. This is the same as log base 5 of 49 divided by 10. So next, using the divisions law, I can write it as log base 5 of 49 minus log base 5 of 10. So 49 is equal to 7 squared. And number 10, we can break it down as 5 times 2. So now, using the power law, move this number 2 to the front. So it's going to be 2 times log base 5 of 7 minus. So for this part, we're going to refer to the product law. Don't forget to put a bracket here. So it's going to be log base 5 of 5 plus log base 5 of 2. So log base 5 of 7 is equal to p. So 2 times p is 2p. Minus log base 5 of 5 is equal to 1. And log base 5 of 2 is equal to m. So now get this thing out of the bracket. It's going to be 2p minus 1 minus m. So this will be the answer. Questions number 7. Simplify log base 2 of 2x plus 1 minus 5 times log base 4 of x squared plus 4 times log base 2 of x. To simplify this, we need to change the base of the log. So here we're going to change the log of base 4 to the log of base 2. But before that, using the power law, I'm going to move this power of 2 to the front. So here we're going to have log base 2 of 2x plus 1 minus. So when you move the number 2 to the front, this will be 5 times 2, which is equal to 10. Next, we're going to change the log base 4 to the log base 2. So 10, put a bracket here. So using the log here, we're going to change this to the log in base 2. So log base 2 of x over log base 2 of 4. And this number 4, we can write it as 2 squared. So next, this log base 2 of 2 to the power of 2. So according to the law here, this will give you the value of 2. So next, I can simplify this tens and this number 2. So now I'm going to have log base 2 of 2x plus 1 minus 5 times log base 2 of x plus 4 times log base 2 of x. So now we can solve for this part. So when negative 5 log base 2 of x plus this 4 log base 2 of x, it will become negative 1. So I'm just going to write negative log base 2 of x. So both terms are the log with the same terms, same base. Therefore, refer to the division law. Now I can write this as log base 2 of 2x plus 1 over x. Therefore, we already simplified these logarithm questions. Questions number 8. Given that log base 2 of xy equal to 2 plus 3 times log base 2 of x minus log base 2 of y. So express y in terms of x. So the strategy here is I'm going to equalize both sides with the logs of same base. Then later on I can do the comparisons. So first, this number 2, I'm going to change it to the log of base 2. Now, refer to the law here, log base a of a to the power of x is equal to x. Therefore, number 2 is equal to log base 2 of 2 to the power of 2. Next, using the power law, I'm going to move this number 3 from the front as the power of x. So it's going to be log base 2 of x to the power of 3 minus log base 2 of y. So on the right hand side, so I'm going to solve this first part here using the product law. So here is going to be log base 2. 2 squared is equal to 4. When you multiply it with x cubed, it's going to be 4x cubed. So next, on the right hand side, using the division law, I can write this as log base 2 of 4x cubed over y. And the value on the right hand side is log base 2 of xy. So now both sides are equal to each other with the log of the same base. Now, I can just do the comparisons. Therefore, xy is equal to 4x cubed over y. Now, here we want to express y in terms of x, which means the y will become the subject of the equations here. So first, I'm going to move this y to the left hand side. Therefore, it's going to be xy times y, which is xy squared. Next, move this x to the right hand side. It will be 4x cubed divided by x. So simplify this, you're going to get 4x squared. Next, move the square to the other side. It will be the square root of 4x squared. So when number 4 you square root it, you will get number 2. And x squared, when you square root it, you will get x. Therefore, y is equal to 2x. Questions number 9. Given log base 2 of b equal to x and log base 2 of c equal to y. So express log base 4 of b over c in terms of x and y. So first we're going to change this log base 4 into log base 2. But before that, I'm going to write this log base 4 of b over c using the division law. Here I'm going to write it as log base 4 of b minus log base 4 of c. So next I'm going to change this to log base 2 using the law here. So it's going to be log base 2 of b over log base 2 of 4. So the number 4 I'm going to write it as 2 square. So here is going to be log base 2 of c over log base 2 of 4, which is equal to 2 square as well. Now, for this part, I can use the product law. I can write it as log base 2 of 8 plus log base 2 of b over, so log base 2 of 2 to the power of 2, refer to this law, is going to give you the answer of number 2 minus. Now this log base 2 of c, we can replace it with y. And log base 2 of 2 to the power of 2, we can replace it with number 2. So this number 8, we can write it as log base 2 of 2 cubed. So log base 2 of b, this is equal to x. So now, this log base 2 of 2 to the power of 3 is equal to number 3. So we can combine these two fractions as a single fractions, as they are having the same denominator. Therefore, it's going to be 3 plus x minus y over 2. Questions number 10. The intensity of a sound in decibels is calculated by using the formula D equal to 10 times log base 10 of P over P0, where D is the intensity of sounds in decibel, P is the intensity of sounds in watts, and P0 is the weakest intensity of sounds that can be detected by the human ears in watts, and it is a constant. In a house, a hot water pump has an intensity of sounds of 50 decibels. So this 50 here is referred to the D of the formula. And a wattage of 10 to the power of negative 7 watts. So this 10 to the power of negative 7 is referred to the P of the formula. While a dishwasher has a sound intensity of 62 decibels. So this 62 decibels is the D for the dishwasher. So A, calculate the value of P0. So for questions A, we're going to use the informations of the hot water pump, as we already have the D and the P. So when we substitute it into the formula here, then we can find the P0. So here, 10 times log base 10 of P. So the P, we're going to replace it with 10 to the power of negative 7 over P0. Here is going to equal to 50. So here is mean 10 times the log base 10. Therefore, I can move this 10 to the other side. Therefore, it's going to be log base 10 of 10 to the power of negative 7 over P0 equal to 50 divided by 10, which is equal to 5. Now, to solve for the P0, we're going to change these log forms to the index form using the law here. So this will be 10 to the power of negative 7 over P0 equal to 10 to the power of 5. So P0 later on is equal to 10 to the power of negative 5 divided by 10 to the power of 5. So still remember the indices. So when you're having the same base and this is divisions, then we can just minus the power. So here is going to be 10 to the power of negative 7 minus 5. So it's going to be 10 to the power of negative 12. Or from this part here, this number 5, using the law here, you can change it to log base 10. So it's going to be log base 10 of 10 to the power of 5. When you do that, so both sides equal to each other with the log of the same base, then you can just compare the value. So it's going to, when you solve it, it's still going to give you the same answer. Now we're going to move to questions B. Determine the wattage in watts for the dishwasher and the hot water pump. So here the hot water pump, the watts is already 10.7. So therefore there is no need for us to find it. So you're just going to find the wattage of the dishwasher. So the wattage for the dishwasher is the P. So here we're going to substitute the 62 into the formula given. So here we're going to get 10 times log base 10 of P, which we're going to find. So now from the questions A, we know that the P0 is equal to 10 to the power of negative 2. And the sound intensity of the dishwasher is 62 decibels. So using the same method here, so this is mean multiplications, move the 10s to the other side. So it will be log base 10 of P over 10 to the power of negative 2 equal to 62 divided by 10, which is 6.2. Next, we can use these rules again. We're going to change these logs to index form. Therefore, it's going to be P over 10 to the power of negative 2 equal to 10 to the power of 6.2. So to find the P, is going to be 10 to the power of 6.2 multiply 10 to the power of negative 2. So solve this using a calculator and you're going to get the answer of 1.5849 times 10 to the power of negative 6. C. A wattage for a sound that exceeds 100 watts. This 100 watts is the P. It's said to be painful to the human ears. State the minimum intensity of sounds in decibels that is considered to be painful to the human ears. So here we want to find the D, which is the decibels. So for question C, to find the D, so it's going to be 10 times log base 10 of. So here the P, we're going to substitute it with 100. And the P0, we're going to substitute it with the value of 10 to the power of negative 2. So here is going to be 10 times log base 10 of. So the 100, we can convert it to 10 square. Now, using the indices that we learned in the earlier part, so same base, the power, we can just minus it when it is divisions. So it's going to be 10 times log base 10 of 10 to the power of 2 minus negative 12. So it's going to be 2 plus 12, which is equal to 10 to the power of 14. So next, using the power law, we can move this 14s to the front. So it's going to be 10 times 14, which is equal to 140. And log base 10 of 10 is equal to 1. Therefore, it's going to be 140 times 1 equal to 140. So the sounds that is the minimum intensity of the sounds in decibels, which is 140, is considered to be painful to the human ears. Questions 11. The population's growth in a certain country is P equal to 2.5 million e to the power of 0.04 t, where t is the number of years after year 2020 and e equal to 2.718. Questions A. What is the country populations in 2020? So in 2020 is which is the current year. So the number of years after 2020 is equal to 0. So for questions A, the populations of 2020 is 2.5 million e to the power of 0.04. So the t here, we're going to substitute it with 0. So here is equal to 2.5 million e. So 0.04, when you multiply it 0, is going to be e to the power of 0. So e to the power of 0 is equal to 1. Therefore, the populations in 2020 is equal to 2.5 million. Questions B. What is the country populations in 2030? So 2030 is 10 years after 2020. So to find the number of populations in 2030, so it's going to be 2.5 million times e to the power of 0.04. Here the t, we're going to substitute it with 10. So here is going to be 2.5 million. So the e here, you're going to substitute it with 2.718 to the power of 0.4. So solve this using our calculator and you will find that the number of populations is equal to 3729407. Question C. In which year will that country populations exceed 50 million? So for question C, the word exceeds here is mean greater than 50 million. So the number of populations is 2.5 million e to the power of 0.04 t. So the populations here exceeds 50 millions. So we want to find the t. So first, we can simplify this 2.5 million and the 50 millions. So here we can cancel 50 and we can cancel 50 on the right hand side and the left hand side. Then I'm going to move this 25 to the other side. Therefore, it's going to be e to the power of 0.04 t greater than 500 divided by 25, which is going to give you the answer of 20. So now, as both sides, we cannot equalize the base to compare the power. So here we're going to use the help of logarithm to continue. So here I'm going to log both sides with log base e. So here you're going to have log base e of e to the power of 0.04 t greater than log base e of 20. So log base e is the natural logarithms. So next, I'm going to use the power law. I'm going to move this power 0.04 t to the front. So times log base e of e greater than, so log base e, we can write it as ln 20. So log base e of e, this part here is equal to 1. Therefore, 0.04 t greater than ln 20. Therefore, t is greater than ln 20 divided by 0.04. Now, using your calculator, you'll find that t is greater than 74.893. So the number of years is in whole number. So the nearest one after 74.893 is 75. Therefore, the t is equal to 75. So remember that the t is the number of years after years 2020. So the question asking you in which year that the country populations exceeds 50 millions. So 75 years after 2020. So the years for the populations exceeds 50 millions is going to be 2020 plus 75, which is equal to the year 2095.